great little arrangements question here. So I'm going to list the 12 children. We've got these two who are twins, A1 and A2, and then another two that are twins, another two, and then we'll go with D, E, F, G, H, I. 6 blue hats and 6 red hats. So let's look at the situation where the twins all get blue hats. We can also do all red hats, but I'm just actually going to times by 2 at the end. Then actually there's no choice. There's all the others will have to have red hats. So there's one way that I could do this. I don't need to then look at all the red hats because I'm going to get another way. Like I said, I'm going to double it at the end. Let's look at the situation where there's 4 blue hats being given out to the twins. And this is actually going to be equivalent to 4 red hats being given out to the twins. So again, I can just find this and then double it. Now, there's going to be 3 different ways that I could arrange this. I could have red, red on the A's, on the B's, or on the C. So let's just make a note of that. It's going to be 3. And then I need to look at the distribution of the hats on the other 6. So I know I've got 2 blues and 4 reds. There's a few different ways to think about this. One really nice approach is to say, right, for the first blue hat, there's going to be 6 choices that I could use. And then for the second blue hat, there's going to be 5 choices. And then all the reds would have to be put down on all the rest of them. But I could put a blue on D and then a blue on G. That is going to be equivalent to me putting a blue on G and then blue on D. So I've actually double counted with this. And so I need to divide by 2. And then I'm going to get that many ways for each of the R's on each one of the twins. So when R is on the R's, the reds are on the A's, I'm going to get 15. When it's on the B's, I'm going to get 15 and so on. I times these together. This is the product rule of counting. So I'm going to get 45 ways. Another approach, I mean, that is a really nice way of explaining it, I think. But another approach, a more general idea, is that we are arranging 6 things. You can write down 6 factorial. This assumes you've seen this sort of notation before. But then 4 of them are identical, so I need to divide by that because as I rearrange these, I'm arranging 6 objects in 6 factorial different ways, but I'm counting way too many times because I've got all these different ways of arranging the R's. So I divide by that, and then I also divide by 2 factorial, or 2. Now 6 factorial is actually 6 times 5 times 4 factorial. I should have probably said this. Like 6 factorial is 6 times 5 times 4. That's what factorial notation means. So it's just 6 times 5 times 4 factorial divided by 4 factorial times 2. The reason I've done that is that then these cancel and I'm left with my 6 times 5 over 2. So we are nearly there. We've got these 46 ways. I just then need to double it because I could have done the same thing with reds. All of reds on the twins and blues on everyone else, or 4 reds and 2 blues being shared, we'd get the same answer, 45. So 46 times 2 gives us 92. Well done.